Welcome to the New Jersey Center for Teaching and Learning chemistry course. This is the first unit, Atomic Origins.
Table of Contents, Atomic Origins. We'll start with the Big Bang, talk about the first elements formed, hydrogen and helium. We'll then move on to heavier atoms, then talk about what's inside the atoms, electrons and protons, and the nucleus. Then isotopes, and finishing up with radioactivity and half-lives.
The Big Bang. The observable universe is made up of remarkable things. We call this stuff matter. Humans have always been curious about its nature. Where did it come from? What is it made out of? And why does it behave the way it does?
Scientists have discovered all of the matter in our universe is made up of only 118 different types of chemical elements, and they're shown here on this periodic table. About 90 of these elements occur naturally.
Okay, so we have 116 elements right now, some made naturally and some made by humans. Where did they all come from? Where did all these elements that make up the universe come from? If you said that the prevailing theory of the origin of the universe is that the universe began with the Big Bang, which is an event thought to have occurred about 14 billion years ago, or more exactly, if you watch the Big Bang Theory on TV, 13.7 billion years ago, you're correct. Scientists have a great deal of evidence that shows that our universe began at a single point or a singularity. This spot was thousands of times smaller than the head of a pin. It was also incredibly hotter and more dense than any object we know of today. This heat still remains in the universe, and it can be observed. It's called the cosmic background radiation. The universe appeared. It began expanding very suddenly and rapidly from the single point. Consequently, every piece of matter, all the stuff that we see today, comes from this small, dense spot. Little dog here, aurora borealis, big building, galaxies. Now, one question is, where did that spot come from? And there's conflicting theories on that too. String theory actually attempts to explain it as the intersection of two previously existing universes. But we're not going to go into that here. It's just very interesting stuff. 14 billion years ago, or 13.7 billion years ago, in the flash of the Big Bang, high-energy photons, which is another name for light particles, collided with each other, forming oppositely charged particles. You hear one charge, here's your charged matter over here, and then here would be your oppositely charged antimatter. Typically when this happened, the oppositely charged matter and antimatter annihilate each other instantly. So let's call this positive matter, this is antimatter. They would be formed from the photons, they'd hit each other and turn back into photons, very high energy photons.
Energy and matter. For reasons scientists cannot yet explain, it is estimated that one particle of matter survived for every billion particles of matter and antimatter that were annihilated. You could win a Nobel Prize if you figure out why. These surviving particles make up the matter of the universe today. 3 types of those particles would form atoms as the universe cooled down. As the universe expanded, both the plasma and the radiation filling it grew cooler. When the universe cooled and stable atoms could form, they eventually could no longer absorb the thermal radiation, and the universe became transparent instead of being an opaque fog. The photons from that time have been propagating ever since, growing fainter and less energetic. And a nice video on the Big Bang can be found here.